Dev by Angel back with another video. This is gonna be the second one of the channel, and today we're gonna be taking on another binary search problem. I've been attempting this problem a couple times, still haven't gotten it right, but I think I know the gist of it. I've looked at the solution for this one, I'm gonna be honest, but I haven't attempted this in a good, I'd say, probably a good 6-7 hours. So hopefully we can just do this off the dome and then make it an informative video for you guys. So here we're gonna have Koko eating bananas. This one is LeetCode 875, 48% acceptance with the difficulty of another medium. All right, so here, let's go through what we're thinking. So you're given integer array piles, where piles I, so this, is the number of bananas in the ith pile. So there's 1 banana here, 4 bananas there, 3 bananas there, 2 bananas there. You're also given integer h, which represents the number of hours you have to eat all bananas. So we have 9 hours to eat all these. You may decide your bananas per hour eating rate of k. Each hour you may choose a pile of bananas and eat k bananas from that pile. If the pile has less than k bananas, you may finish eating the pile, but you cannot eat from another pile in the same hour. Return the minimum integer k. Okay. So what we're solving for? What we are solving for. It's going to be k, which is minimum eating rate, I guess you can say. Minimum eating rate. All right. And then so here we can clearly define, so because it's a binary search problem, if you take a look at piles, so if anything, we just do this, so 1, 4, 3, 2. If you take a look at this array that they give you, or list, I guess you can say, since we're in Python, it doesn't really, you won't really think binary search, right? But the thing is that we're not solving for this though. We are solving for the minimum eating rate. So basically, the solution, it'd be like the, so obviously here the output is 2 right there and 25 here. So it has nothing to do with the inside. So I mean, these kind of align, but that's not the point. But so this is basically completely separate from this. So here, using this one as an example, we basically build our own array, right? So we'd have this, and then we'd use binary search on this one to see. So 4, is that the lowest? No. So bringing the right pointer down to here and redo the whole binary search again, right? Or 4, if that's not fast enough, then we bring the left pointer and bring it up here. So that way you continue the binary search. This is really the array that we're using, or list. And so what it really comes down to is, how do we know what's our bottom and what's our top? So what's our min and what's our max? So to solve our min is, it's pretty simple. So the min, just looking at the problem using common sense, the minimum is 1, because you can't have 0. If you have 0, then Koko not eating. You know what I mean? Koko gonna starve. So the minimum is 1. Whereas the max, so our upper bound, our max, if you take this one for instance, this one actually is perfect. So let's grab that. Our max. So the thing is that h hours, so that's actually another good thing to prerequisite. So h hours has to equal the length of the array. You may say, hey, Dev by Angel, why is that, right? So I'll show you here. So let's say this one, hours equals 3, and you decided to go with the eating rate, k equals 1,000. But Koko could eat 1,000 bananas per hour, right? But here's your constraint. You may finish eating the pile, but you cannot eat from another pile in the same hour. So that means if this is 1,000, this Koko was done in a minute, right? If that. But she has to wait the full hour. So now Koko's done with this pile. This is now 2. 4, Koko is done with that in 2 minutes. If that, this one's done. Now it's 1. Koko's done with this one. Now it's 0. So she doesn't even have time to get to this one. So the hours has to be the length of this, right? Has to be the length of this. So our max is just going to be the highest number in there, right? So, because in here, let's say k equals 24, right? You have 4 hours to do it. This one's going to take 2 hours. So now we're down to 2. This one's going to be fast. Now we're down to 1, 23, still 0. So that's what I mean by that's our max. So our max is going to be the highest number in the array. So we'll just do max of piles, right? So these are our bounds right here. So this is what would create this. So if we're actually using this one, for instance, our bound minimum is 1. Our maximum in here is 4. So 2, 3, 4. This would be our array. And we're going to be using this one to continue going forward. So let's delete all that. Let's actually get into the problem. All right. But that's how I'm trying to teach the problem, so that way I understand it better as well. You know, it's a learning process for us all, right? All right, so let's get through this. So obviously we have our left pointer, right? Let's keep all our notes actually. If anything, it's probably good to keep. All right. So we'll have our min. Well, that's probably not good. So we'll have our left is equal to 1. Our right is equal to the max of piles, right? So this is what we're talking about here. And so what we're actually calculating is the total piles, right? So total time equals 0. All right, so we'll have our normal binary search, right? While less than right. Okay, so this is where it stumped me, right? So we had to, like a normal binary search, we gotta get our middle. That's gonna be our k, right? It's gonna be our k. So we're gonna have our left plus right. If you don't know how to do binary search, make sure you would, if anything, make sure you do this one. They put in a very, I love LeetCode because they put in a very good order. Make sure you do this one first. If you don't know binary search, you should not be attempting these other ones. But you should be able to do binary search off the dome, all right? So, all right. So this would be our middle. So based off of this code so far, we have our left using, we're not going to ignore that one now. We can ignore the piles. We already created this. Create this. All right. So using this array right here, we have our left right here, which is 1. And then, oh, well, no, if anything, see, look, that's where it tricked me up because we're not using this array. So left equals 1. So this creates our own, right? 1, 2, 3, 4. Left equals 1. Right equals the max of piles. So if anything, these numbers aren't even in here right now. This is technically what we're dealing with, right? So if anything, there's a better way to, we'll do, so right now we're at 1, and the other one is 4. Maybe that's better visualization, right? Here, we'll put these on separate. I guess that looks good, right? So this is what we're looking at right now. But, so what we're going to have to do is we're going to have to see whether this middle integer, so k equals left plus right, divide that by 2. 1 plus 4 is 5, divide that by 2, blanked, 2.5, right? But we're doing integer division, so 2.5 gets rounded down to 2. So now we have 2 in here. This is k. So L equals 1, R equals 4, K equals 2. So using this one right here, we get to see if this is a valid output. How do we check that? We compare it, so we would just divide this by 2, right? So we're gonna, here we are, we're gonna do 1 divide that by 2, 4 divide that by 2, 3 divide that by 2, 2 divided by 2. And we're gonna see how many hours this takes. This equals 0.5, and then we're gonna round up to 1, that's 1 hour. This equals 2, that's already pretty simple. It's gonna be 2 hours. this equals what, 1.5 or something like that. That's gonna round up to 2 hours, and this one equals 1. That's clearly 1 hour, right? So here, so let's before we get ahead of ourselves, let's do this real quick, right? So we're gonna have for pile, for pile in piles, right? So here, if anything, I like to use i's instead. Makes it easier to differentiate, right? For I in piles. So for each one in piles, what we're gonna add to our total time right here. So our total time is plus equals. This is, you have to use math.ceiling. So this is how you round up. So math.ceiling is how you actually round up to the next one. So here was 0.5. Use math.ceiling to round up to 1, because we can't have half the time because you need to use the full hour, right? So math ceiling, that's going to be, so what we're dividing is I divide that by K. You know, K is 2 right here, right? So that gets us our total time. So now we got to check to see if that total time is less than or equal to 9, because that's our boundary, right? So if total time is less than or equal to, because if it's equal to 9, we're chilling, but if it's more, we're cooked, right? So if it's less than or equal to h, right, which is our time, less than or equal to, then we obviously got to get a resolution, our res, right? So our resolution, no matter what, we're always going to have, I swear it says in somewhere in here, which represents, you may decide, blah, 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 blah. Well, because of the hour constraint, we're always going to have, what's it called? A solution. So the resolution is basically just right so far. So, I mean, yeah, we'll put it like that. But resolution is basically the max of the pile so far right now, right? Let's say in this instance right here, right? The resolution will come out correct. But, all right. So these are our variables for now, all right? I think that should be our variables for going through the future. But, all right. Total time. So now our resolution is going to be equal to K, right? So resolution is equal to K because we found the correct one. In this problem right here, that is actually the correct one, but that's the catch. It could be the correct one, but we don't know if it's the smallest, right? So because total time is less than or equal to h, we know that there could be some that are smaller, right? So how do we get some that are smaller? So we have our left pointer, we have our right pointer. How do we know to get them smaller? You guys a couple seconds to think about it. So we want, to give you an idea what we want right now because we know this one's good, we want k equal to 1. So using this formula right here, how do we get k equal to 1? We reduce the right pointer. So the right pointer has to now be smaller. Because now if we reduce this to 3, right? So here we'll do, we have a variable named right. So right is now equal to k minus 1, because k is our middle right here, right? So right is now equal to k minus 1. So k minus 1, 2 minus 1 equals 1, right? So now that's what right equals now. So we'll update this. Right is equal to 1. K, now we're going to have to recalculate that. So we'll actually, I'll put the else to remind us. But now, so now going back into the iteration, going back in here, check to see if we have anything smaller. K is now equal to left plus right. 1 plus 1. Divide that by 2. That equals 1. K is now equal to 1. Right? We're going to go in here. For I in piles. We're going to do that, blah, 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 blah. If total time is less than or equal to, so if anything, this one would actually, so if we do 1, 1, 1, 1. This is now 2 hours, 3 hours, 4 hours, and 1 hour. 4, this is what, 5, 8, 10. This now equals 10 hours. We are now past, right? So if anything, what we would do, we would reduce the left pointer. Because in here, we reduced the right pointer. So now we reduce the left. So we would do left is equal to k plus 1 because we want to increment it. This doesn't really give us a good example of that. But basically, once we do that, k plus 1 in this instance, k plus 1, so k is 1 plus 1, it's going to equal 2. So now, because this equals 2, right equals 1, so 2, 1, now this is false, right? So now we would just return res. And this should really be it. I didn't really give you guys a good example of this guy, but it's basically same instances, right? So if the total time is more than h, then we would increase the left pointer because we need it to be a faster eating rate. So I'll give you guys an example real quick. So if the total time was higher, so like in this instance right here, 10 hours. So this was 10 hours, that's too long. Koko can't eat hard bananas. So we move the left pointer. So left is right here right now. Right is all the way down here. We would just move this one upward, right? Keep the right here. So now when we get our middle, it's going to be a faster eating rate. So that way the total time decreases. A little counterintuitive in my head, but that should really be it should be everything. Let's run it. All right, got accepted by both test cases. Let's see. Submit. And we got the wrong answer cooked. Let's see what went wrong. Obviously, you can see how many times I attempted it, right? This is all in the morning, so I wasn't lying. I did wait a little while. Piles 3, 6, 7 here. We'll use this test case. I won't run now. Let's see what's wrong with this guy. You were output 6, expected output 4. 3, 6. Oh, we'll use this as an example. Let's see. Let's go through our code, see if the logic passes, right? Maybe we missed out on something. Piles equals 3, 6, 7, 11. So we have our, with the eating rate of, well, with hours of 8. So we got, actually, I believe we got it too high. Your output 6, expected output is 4. Let's see. Oh, all right. So we have our array, right? Put this in comments. So we have, it's going to be 1, and then we have 11. 1 plus 11, 12 divided by 2 is 6. 6. K equals 1. Oh, no. K equals that. Left equals that. Right equals that. Right. So I'm here for I in piles, blah, 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 total time. Yes, so for I in piles, we do that whole division, blah, 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 6, 6. So 6 right now. Let me deal with my phone real quick. Let's make sure to see if it adds up. So 3 divided by 6, that's 0.5. So that's 1 hour, 6, 2 hours, 7. No, sorry. So I don't even need to do this. So 1 hour, 1 hour, 2 hours, 2 hours, 4. This is 4 right here, 4 hours, and then 6 hours. All right, so that makes it. So we are good. So that gets us our total time. If total, oh, that's the issue right here. We put the total time outside. So basically, because we had the total time outside, in this while loop, it just kept adding and adding and adding and adding, right? So here we have our total time of what? That was what, 6 hours? but because we re-looped it again, right? It goes through it again, but the total time is never reset. So we have to move this into here. There we are. And then now we can submit. Oh, oops. It's always these comments. God damn. All right, now we can submit. And boom. So I was scared me a little bit, and I didn't know if I was gonna be able to solve it, but we got it. So just the code. Relatively, the code is simple. The thought process is what's hard. You know what I mean? So I'm gonna try to do another one. I'm gonna try to do this one off the top, but that'll be in the next video. I don't know if it's gonna be another binary search or if it's gonna be. I was thinking maybe doing a sliding window or something like that, but we'll take a look. Thank you guys for tuning in. Any questions, feel free to leave in the comments. I'm a small channel, so I'll be happy to answer them. Even if I don't know, I'm just gonna let you know I don't know. I don't want to give you guys any wrong answers. I'll only let you know if I'm for sure about the answer, this and that, but I'll always make sure to do my research. But thank you guys for tuning in, and I'll catch you on another video.